In this video, we'll be looking at another problem involving linear and angular speed. Let's look at our formulas first. One of the formulas that we can use to find linear speed is velocity equals arc length divided by time. Another formula for linear speed, velocity equals the radius of the circle times the measure of the central angle in radians divided by time. Or we can use velocity equals the radius of the circle times the angular speed, omega. Now, angular speed formula is omega is equal to theta over t. Theta is a measure of the central angle in radians. So the example that we'll be doing is a belt runs a pulley of radius 5 centimeters at 120 revolutions per minute. We're first asked to find the angular speed in radians per second. Well, we know 1 revolution is the same as 2 pi radians. Since we're going 120 revolutions, we multiply by 120 and we get the angular speed of 240 pi radians per minute. So multiplying 2 pi times 120 changes that to radians per minute. We're asked to find the angular speed in radians per second. So this unit of time, minutes, we need to change to seconds. So we make that 240 pi radians in 60 seconds and then simplify that fraction and we get 4 pi radians per second. Now we can also do that problem with unit multipliers if you like using unit multipliers. If we start out with 120 revolutions per minute, that's in our problem. And then to get rid of the unit revolutions, we know 1 revolution is the same as 2 pi radians. So our 1 revolution is in the denominator. We would cancel that off. And then to get rid of minutes and go to seconds, we need our minutes in the numerator and then seconds in the denominator. And working this out, we also get 4 pi radians per second. Now the next thing we're asked to do is to find the linear speed in centimeters per second. Well, since we know from part A that the angular speed is 4 pi, then we can use the formula velocity equals radius times angular speed. That's what omega is right here. Our radius is 5 centimeters and our angular speed is 4 pi. So we have our velocity is 20 pi. Now if we need that in decimal, we can multiply 20 times 3.1415, and that comes out to be about 62.8, which we would take to 60 since my original problem, the least number of significant digits was 1.